getting in the car. So to honor that, we are broadcasting this live to the world at the same exact time we're sharing it with our internal company. You are now on this journey with us, and let's see where we're going. Next slide. Like I said, this is a roadmap presentation, which means in Q4, where we stand today, this is what the men and women of Red Hat are coming to work and working on. This is our best estimate of where we're going. Now, things will evolve. And in fact, in this presentation, in the roadmap presentations, things evolve and change a lot. So it's good to check back in with us. We're going to be doing this once a quarter, so you'll get to see the change and the evolution of the features. You know, the lawyers want me to mention that you should not buy a product based on its futures. Those futures will change. Buy the product because it's awesome right now, because it's going to help you with a problem. And that is what we're going to dive into right now. Next slide. I have brought with me some awesome people, some experts in their field, and we are going to dive in to core Kubernetes. We're going to dive into the top of the stack. We're going to go into the infrastructure, and we're going to get into the developer experience. Next slide. When you look at OpenShift, it is a platform. It is a hybrid cloud platform. It's going to help you get the most out of your investments, whatever investment that you may have chosen. And we're going to shine a light on what hopefully made you buy that investment. We're going to make it easier to use those things. We're going to make it easier to push to production. We're going to make it easier for you to capitalize on this technology stack. And we do it in the core Kubernetes layer. We do it at the top of the layer services, and we do it from a multi-cloud point of view. Next slide. This particular presentation is going to get deep into what we're going to do in January. It might bleed into February a little bit. What we're going to be pushing out in Q2, and then we're lumping the second half of 2021 together because things get, you know, a little less clear the further out you go. But like I said before, this is an honest assessment on what we're all striving for in both our communities that you're involved with and within the company itself. And with that, I'm going to hand it over to Catherine. And Catherine, why don't you take us through the core?
Thanks, Mike. Next slide, please. In the following slides, we're going to kick off the core platform roadmap with a look at the overarching themes, which form the basis of roadmap and how we guide based on what we've prioritized. So this is influenced by industry and market trends, technology, upstream directions, and most importantly, customer feedback. And the insights given to us through conversations with customers, RFEs, customer cases, bugs, and other methods like voice of the customer sessions. OpenShift is the foundation of Red Hat's open hybrid cloud strategy, enabling users to have a consistent operational and application experience from the data center to the cloud to the edge across different infrastructure types, providers, hardware architectures, and accelerators. Basically, OpenShift everywhere. This also means users can continue to ask for more flexibility and choice while focusing on maturity for security at every layer of the stack. You will see that reflected on the first two pillars here. We'll also find containers, Kubernetes, and OpenShift adoption is increasing with the need for support for newer workloads, such as AI, ML, and databases. So enabling newer workloads is definitely part of our plan. Finally, our customers not only scale both in terms of size and number of clusters, but also in terms of maturity and sophistication of their deployments. We see observability, management, automation as the third pillar. You will see declarative policy-driven management and automation of multiple self-healing clusters, application deployment across these multiple clusters, some of the areas we'll be investing in. Next slide. So let's kick it off with OpenShift install and update. We're going to be focused on a number of key areas there. For the hybrid cloud, we're enabling OpenShift to be deployed on even more platforms, including Alibaba, AWS Outposts, Azure Stack Hub, Equinix Metal, IBM Public Cloud, and Microsoft Hyper-V. We're also extending our existing provider support to cover more regions, as well as additional cloud instances like AWS C2S, AWS and Azure China, and planning to make reliability and scalability improvements, such as adding support for vSphere multi-cluster deployments. The next one on this list is for restricted networks. We're planning to release an on-premise version of OpenShift Update Service, enabling viewing of graph data information right from the console, which will allow you to see what upgrade paths are available for that given cluster, and add support for leveraging on-disk images when installing OpenShift. Finally, we'd like to improve the OpenShift deployment experience with better documenting of cloud credential permissions for both day 1 and day 2, support for customer-managed disk encryption keys, Azure and GCP, and moving the control plane to be machine set managed for automated node recovery. Next slide. So that brings us to the core themes, compute, networking, and storage. Let's start off with workloads. In the past year, we have added a number of features to compute, networking, and storage, such as NUMA alignment with Node Topology Manager, Remote Worker Node, Multis for high-performance networking, to name a few. This was in response to the needs for new workloads and markets that include AI, ML, telco, 5G, and edge. But we're doubling down on those markets, as well as the workloads that run on them. And we'll continue to add performance, scale, and scheduler extensions to serve those markets. But also plan to start addressing the HPC market. One is scalability, stability, and scale. When we look at these new markets, we continue to pay attention to the needs of our existing markets, the enterprise market, and bring you advanced features that will help you manage or better manage application certificates, introduce networking support for multiple clusters in an autonomous system with BGP, high-performance networking features, and more. We increase coverage for CI/CD testing of OpenShift while adding telemetry and diagnosability to assist SREs in the field to decrease mean time to repair. And the last one here is partner and technology integrations. We continue to support a broad ecosystem of partners through more certifications of providers for networking via CNI, storage via CSI, and provide more capabilities with extensions to the core scheduler that can be node topology, load, or specialty workload aware, such as gang scheduling and HPC and grids. Next slide. So we're excited to introduce upcoming support for Windows containers, customers to run Windows workloads on their clusters. This involves letting Windows nodes run Windows application containers and RHEL nodes run RHEL application containers, with OpenShift orchestrating them as building blocks to compose your next generation applications. We provide full coverage for moving Microsoft Windows workloads to OpenShift, enabling users to run legacy Windows VMs, OpenShift Virtualization, .NET Framework containers on Windows Worker nodes, and .NET Core containers on RHEL or RHEL Core OS worker nodes. At the heart of the solution is the Windows Machine Config Operator, which automates the orchestration of adding Windows nodes to your OpenShift cluster, enabling Windows Server workloads to run on OpenShift 4.6 or later. The operator allows a cluster administrator to add a Windows Worker node as a day 2 operation with a prescribed configuration that allows it to join the OpenShift cluster and enable scheduling of Windows workloads right on that new node. A prerequisite for this, probably just an important note here, is that the cluster must be configured with hybrid OVN Kubernetes networking. Next slide. So continuing with that thought, we're going to jump into the roadmap for Windows containers. So the general availability of the Windows container, the operator, will be on 12/14, so it's fairly soon, 4 days away. The Windows machine config operator will be available from the in-cluster operator hub. Once installed, you'll be able to deploy Windows nodes right on your cluster, and the operator will be available for AWS and Azure at the time of GA, with support for other platforms such as vSphere and bare metal coming later. Finally, logging, monitoring, storage solutions for Windows container workloads will be also available after GA. Shifting to compute, so ARM has been in the news lately with recent acquisition by NVIDIA, as well as the adoption of ARM architecture by Apple in their new Macs. ARM also forms the basis of a number of technologies, including DPUs and smart NICs. Therefore, OpenShift for ARM and enablement of the next generation of bare metal as a service with OpenShift is an important focus area for us going forward. These changes will enable a new cloud-like way to do software-defined hardware security and isolation, networking, and storage in the data center. We're also planning to provide more capabilities with extensions to the core scheduler targeted again at running AI/ML, as well as HPC workloads. As a first step, we're introducing scheduling profiles. So they're defined as several schedule plugin configurations that represent most common use cases and can be enabled by the kube scheduler operator. And to round it out on the side, let's shift to control plane. So several new enhancements are planned for the control plane. First one is productizing the cert manager or jet stack. The cert manager helps automate certificate management. It builds on top of Kubernetes, introducing certificate authorities and certificates as first-class resource types in the Kubernetes API. We're working on providing a Red Hat supported operator for Cert Manager that will be available to all workloads running in OpenShift, except the Bootstrap components that need certificates before operators exist. So those include out-of-box operators that are supported as a day 2 configuration, like OLM operators, middleware, software from Red Hat, as well as applications deployed by the customer. The next one on the list here is custom route name and certificates for OpenShift cluster components and users of identity providers that use URI scheme in their subclaims to be able to log into OpenShift. Other significant highlight include providing automatic certificate generation or rotation for direct pod-to-pod communication, similar to the service serving certificates operator. Finally, customers will be able to easily integrate with external KMS solutions by using existing Kubernetes KMS provider capability and existing KMS plugins, including those provided by major cloud providers. Next slide. So we're going to move to networking. So customers are asking for more advanced features than ever for our networking. And we've been delivering upon those asks in our next generation networking platform, OVN. So examples include east-west encryption with IPsec for customers with regulatory compliance requirements, full IPv6 support for telco, performance improvements via hardware offload to SmartNICs, BGP support with externally advertised Kubernetes services, and eBPF for a high-performance replacement to IP tables to remove scalability limitations. Network observability is being enhanced as customers grow to multiple clusters by adding new metrics and telemetry, but also presenting the information in a way that is more easily digestible by networking and security admins. Shifting to network edge, OpenShift continues to align to upstream Kubernetes, and Red Hat's leadership contributes to Ingress v2 Service API, which defines our next generation Ingress solution for OpenShift. Builds on the promise to close the gaps between Red Hat routes, Kubernetes Ingress v.1, version.1. Egress router, a popular customer method for associating a source IP address, is completed in OVN as we close the gap between OVN and our current networking solution. We've also added day 2 configurable custom domains for customers that want application naming that aligns with their corporate DNS. In addition to performance and scalability enhancements in HA Proxy 2.2, we deliver on several customer requests for configurable settings such as a variable number of threads, custom error pages, and more. OpenShift will also provide support for IP failover image, a highly anticipated customer feature that adds a means of providing simple HA for cluster service external IPs. Shifting to storage, in the nearer term, we are going to be supporting snapshots with CSI drivers that do have support now, with OCS and CNV, which already support snapshot. This will be what is known as crash consistent snapshots, what you get if you remove power from a system with a journaled file system. Our work to transition to CSI drivers is bearing fruit with some tech previews graduating to GA, including AWS, EBS, GCP EPS, and Cinder. There are also some more tech previews that we continue to convert our core in-tree drivers. The other thing here is the Csi Migration piece, which allows seamless transition from in-tree to CSI drivers. We see this happen first for the Cinder CSI driver, but migrations for others will follow after that. This has become a main focus as a lot of the in-tree drivers have been deprecated upstream. That means they will be removed once the CSI migration is positioned to GA for them. In the long term, we're going to look at other operators like ephemeral and object storage. And at some point, we'd like to remove flex volume since CSI support will effectively replace this. Next slide, please. Next, we'll talk a little bit about Red Hat's observability story. So OpenShift provides several different components that helps users understand and troubleshoot problems quickly. At the multi-cluster level, we have advanced Cluster Manager, which provides cluster health observability across your entire OpenShift fleet and on the single cluster level as well. So we also have OpenShift monitoring and logging, and that gives you a more detailed view of what's going on inside your cluster, and that's built right into the console. The key focus areas here are the hybrid cloud observability, so extending our reach and exposing more multi-cluster capabilities to support our hybrid cloud observability story, and cluster observability, so enriching our in-cluster observability experience for better and easier troubleshooting at a higher resolution. Next slide, please. So in the near term, for both monitoring and logging, we'll continue to double down on ability and quality of our solution, specifically doing a non-feature release in 4.7 as we work through the backlog and test infrastructure. So for monitoring, we're planning to enhance our core capabilities, for example, to allow more customizations of the built-in experience and support for multi-cluster metrics aggregation scenarios. We're also going to be continuing to provide a top-notch connected native monitoring experience inside the OpenShift console. For logging, we'll be focusing on introducing some critical high-interest new features such as JSON support and more tenancy capabilities around log forwarding. Architectural changes to provide a more lightweight easier to operate logging experience by introducing an alternative log storage solution. And then finally, better native exploration capabilities for logs inside the OpenShift console. For multi-cluster, we're going to be building upon or going to be adding additional cluster value in ACM cluster health monitoring with Thanos and Grafana, providing enhancements to metrics collections, enabling customers to allow their own custom metrics to be gathered and sent to the Thanos hub. Customers can define custom Grafana dashboards from a Git source, ensuring they not only have a read-only multi-cluster health and optimization dashboard out of the box, but consistency in their customized Grafana dashboards as well. And as we get to the last area, slide, I'm going to focus on, for our cluster infrastructure roadmap, we're continuing to move forward in our focus of bringing value and additional features and exposing them to our customers. There's a lot planned in terms of new key features here. The first thing is to mention is proxy support. So historically, the machine API did not follow the global proxy settings. It will from now on. We are bringing this change as part of a zStream release. From that point, they'll obey HTTP proxy and HTTPS proxy settings. So while we believe there will be a limited impact to our end users, this is something to keep an eye on. Also in the near future, we are starting down the path of supporting out-of-tree cloud providers. So just like CSI on the storage side, upstream is moving to cloud providers not being part of the core Kubernetes. This means eventually removing all existing in-tree cloud providers in favor of their outer-tree equivalents with minimal impact to users. The first one we will do is on OpenStack, which will be followed up by work on the other key cloud providers, AWS, GCP, Azure, as part of our midterm goals. This is also actually tied to a lot of dependencies and other teams. So the outer-tree cloud providers will require CSI drivers as part of for the storage. So pretty much a lot of this work is all tied together before it will be delivered. And then in a midterm, we're also looking to be able to treat the control plane compute as machine sets, as I mentioned earlier, and also working with availability zones for long-term goal of aligning with upstream and bringing a fully realized vision of a multi-architecture, multi-cloud cluster to OpenShift. So shifting to multi-arch, we're continuing to move forward aggressively for the multi-arch work, focusing on IBM systems, but we're also planning to add support for an additional architecture. In the near term, we're bring in some of the storage options that didn't make the last release. We're also responding to customers' ask for supporting OCP and on KVM on Z. This is because they don't want to run them. Sometimes because of cost, sometimes because of in-house expertise. Either way, we're going to be looking to add support there. Midterm, we'll also be looking at Multis and catching up on the NVIDIA GPU support, though the latter is a dependency on NVIDIA. In addition, we're hoping to introduce ARM support for bare metal installs. This will probably be in the pilot initially, but moving to a tech preview as fast as we can. Initial support will be only for Genius clusters, so meaning no mixed architectures as of yet. Longer term, we're looking to expand support for our own stack with Rev IPI and OpenStack on the list. We're also getting, also on the roadmap is the IBM Cloud Infrastructure Control Integration. This will be a way of delivering the vast benefits of installer provision infrastructure to power in Z. The final item is actually Heterogen. So this has mainly come up due to our move to ARM. This particular use case requires ARM worker nodes to be part of a cluster with a different architecture. But this, unfortunately, is a big effort and affects many areas of OCP. So it's going to be on the longer side before we can actually support this. And to round this final list out, multi-cluster with ACM. We enhanced our existing investment in OPA integration by bringing the development of the OPA operator via policy in the ACM governance risk and compliance pillar. ACM also offers GitOps of Argo CD and does it at scale. ACM allows configuration to grow with your clusters automatically. As you deploy and import new clusters, ACM configures and deploys applications and configurations. This is GitOps that scale. Submariner will be included in ACM as a tech preview, opening up the possibilities of multi-cluster networking, especially in load balancing AR scenarios. And then finally, we continue to invest in supporting our customers wherever they run OpenShift, adding existing support matrix, ensuring ACM hub and managed clusters are working for both Azure, Red Hat OpenShift, so ARO, as well as dedicated service running on Red Hat. Thank you, and next slide.
Okay, Kubernetes native infrastructure. Next slide. Okay, so focused on on-prem environments, K&I provides the simplicity and agility of the public cloud in on-prem environments, right? And to do this, we are keeping a consistent OpenShift experience across both footprints, public and private clouds. And among other things, K&I is addressing container adoption growth, but while still running virtual machines, we will talk about this later, along with containers, right? By running OpenShift clusters on bare metal node. Next slide. And we're going to start with bare metal. And if you remember, in OpenShift 4.6, we introduced bare metal API to our family of installers. And in this model, in the K&I model, the OpenShift installer is aware of the infrastructure provided by the bare metal nodes, treating bare metal nodes and interacting with them as you would with machines in any other cloud provider, right? This is where the magic is in this part of K&I, right? The ability to treat bare metal nodes as if they were machines in AWS, in Google Cloud, or in any other platform. The resulting cluster is an OpenShift cluster on bare metal, but an OpenShift cluster on bare metal that's aware of these bare metal nodes it's running on and managing as well. Let's see what's next with this on the next slide. Okay, as part of the installation. So I think one of our biggest additions in K&I is going to be the fully supported assisted installation from cloud.redcat.com. So this is an online assisted installer, an online experience to deploy your cluster on bare metal, making it easier, very easy, with very low entry bar, with very few pre-requirements to get clusters up and running with a UI installer that's online that guides you through the installation process, right, to get your cluster installed. Then let me highlight a few other things in here. For example, and now more general, not only about the assisted installer to install from an online at cloud.redcat.com. We are adding improved validation. So, okay, let me start again. So in OpenShift 4.6, we introduced the bare metal API. 4.6 is out. We have had feedback of users in both telco enterprise environments telling us, well, in this first few weeks, a couple of months, this is what we are learning. And we are introducing things like improved validations. One of the things we learned is, look, this fails, but it takes a while. I want it to fail fast and tell me exactly what am I missing. So based on that, we are improving the user experience. We're also adding features that initially they are coming mostly from telco customers, but let's not forget about our enterprise type of customers, which we have loads, and the interest is really high as well. With automating and the ability to deploy fully automated clusters on bare metal, right? But the highlights here, you will see that, for example, UEFI Secure Boot is an addition that we are adding that anyone can benefit from that, but we learned that telco customers require this. Maybe you're passing your security audit, and if you don't have UEFI secure boot, well, somebody's going to flag it right during the audit. Similarly, we are adding Fips mode support. Fips is supported in OpenShift, but we are adding the logic to the installer in API so that you can say, hey, I want to have it enabled, and you can do that at installation time. Then on the management side of the clusters deployed with KNI, well, again, we are learning about how people are using this cluster with bare metal and what gaps do we have. And one of the things that you have with bare metal is when you reboot a node, it's not like rebooting a virtual machine, it's going to take some time. And we are working on faster recovery times after a bare metal node failure. Similarly, we are also automating the recovery, in this case without BMC management. BMC is what we use to manage the nodes in general. Not everyone is going the nodes to be able to be recovered after failure, right? So we are doing this through a process we called the poison pill, right? More things that we are doing, we are learning that, especially in the telco market, customers want to have specific sets of BIOS settings configured, right? And those are needed by workloads that need to be deployed only on nodes that are configured in the specific way that telco workloads expect, okay? So in order for us to do this, we are adding support to get and set BIOS settings and to also schedule the workload placement based on those, right? And then on the networking side, still on bare metal, what we are doing is, well, host network configuration. This is the node you install the OpenShift cluster. We want to be able to give you a way to configure the host networking in any way you want, with VLANs, with bonds, with the standard configurations that you can do manually in your operating system, but now automating them for you to do it on day one during the installation. Static IPs, similarly with the hosts that you are going to use for your cluster, we are learning that not everyone wants or can have DHCP. So the ability to configure static IPs for your nodes is something we are working on. And as part of deploying an OpenShift cluster on bare metal with API, something that we do is we add a load balancer. It's a load balancer right now based on KeepAlive and HA proxy, and DNS based on NDNS and core DNS. Well, customers are telling us, well, I may want to use my own load balancer and my own DNSs, not the ones provided by you. Okay, so we are adding this ability to enable and disable those. Let's see more things about KNI in the next slide. And now I would like to talk about OpenShift Virtualization, again, still in Kubernetes native infrastructure. And well, I would like to suggest you to read the blog post that is linked in this slide, what's new in OpenShift Virtualization in OpenShift 4.6. Remember that we went GA in 4.5. And with that release, we've been focused on making VMs easier to create and consume in Kubernetes, right? We've also demonstrated performance parity for virtual machine workloads in OpenShift for even the most demanding enterprise databases. And more of this in the blog post link in this slide. Now let's see a few more things about OpenShift Virtualization in our next slide. Okay. So let's start by core as part of OpenShift Virtualization and core improvements for virtual machines in OpenShift. I will highlight a few of them. For example, running compute-intensive workloads like AI, ML
Raymond?
by a GPU.
Raymond?
Yeah. Yeah.
I'm so sorry to interrupt you. The audio is a little spotty. Can you try turning off your video and see if that clears up? It's been spotty, just internal and external. Thank you.
Is it better now?
I think there may be some improvement. I'll let you know.
Okay, I'm going to keep going then. So as part of the core, right, running intensive workloads via ML, via GPU pass-through, and also via vGPU. This is something we are adding to OpenShift Virtualization. Deployment of to public clouds where bare metal is offered. Remember that it's obvious, right? OpenShift Virtualization requires OpenShift to work on bare metal nodes. But we are also having bare metal nodes in public clouds, like AWS and IBM Cloud is where we are adding this capability as well. We're working on this. And we're also working on tooling for match workloads migration from vSphere and REST platforms into OpenShift virtualization. Then on the network side, and I hope I'm not breaking up anymore. Hopefully you can follow me.
Raymond, the audio is still a little spotty.
Okay.
So we may want to, is it possible for us to move forward a section and come back to your slide? You may want to test your connection because it is very difficult for everyone to hear.
Yeah, okay. So move to the developer platform service and then I'll start from here.
Next slide, please. Hey everyone, Ollie Moburn here, Product Manager for OpenShift Console. Today I'll be guiding you through a journey of developer and platform services with Csi as well. So first I want to talk about our customers. Each of our customers has different needs and requirements, as they should, since they all are unique businesses. We as OpenShift, aka the platform of platforms, need to enable our customers to easily configure, customize, and extend the OpenShift platform in order to meet our customers' business needs. The developer and platform services is specifically engaged in removing all friction from adding and configuring services on top of the platform, to developing and deploying applications to the platform. Following areas that highlight how we approach that. So you have operators in Helm. These are key mechanisms for packaging and managing add-on services. Then you have the console, which seamlessly ties everything together and provides a user with exceptional user experience. Next, we have Quay, which is our central registry that helps power deployment of services and applications. After that, we have Serverless and Service Mesh, which provides an easier way to develop and run applications in Kubernetes with a secure day 2 story. Next, we have DevOps and GetOps, which facilitate application delivery and management. And finally, we have developer tools, which empower developers to take full advantage of the OpenShift platform. All in all, our goal is to provide our customers with a Kubernetes platform that will help them succeed. Next slide, please. The OCP console has 4 high-level themes which we focus on with every release. Our first theme is about making developing, building, and deploying applications to OpenShift as easy as possible, with the goal to provide developers everything they need in a fashion that is consumable by them. Below are a few of the highlights you can expect to see in the future. You can look for things like new experiences for functions and integrations with managed services and much, much more to come. Our next thing, we focus on teaching our users about Kubernetes and the ever-fast changing ecosystem. Look for improvements to Quickstarts and then features like CLI shortcuts that will help our users automate what they just learned in the UI. The next thing we have is about managing OpenShift. Look for the console and ACM to converge into a single interface for our customers. The need for multi-cluster management grows more and more important every day. Finally, the last thing we have is enabling the extension of the platform. So look for the new dynamic plugin framework that will enable operators to easily add and integrate new UI with the OCP console. Let's also look for general improvements to interacting with operators on the platform as well. Next slide, please. So let's dive a little deeper into dynamic plugins. We created the dynamic plugin framework to empower operators to create exceptional native UX experience on top of OpenShift. Previously, in order to do native integrations with the console, or add-on operators like, for example, OpenShift Serverless or pipelines were limited to use our pre-existing static plugin mechanism. The static plugins bound those operators' UI code to the console itself, not allowing our add-on operator teams to release new UI code on their timelines. Now, with the new dynamic plugin framework, teams are able to update their UI code with their operator release. This just adds another level of flexibility for our additional add-on operator teams. In 4.7, we're building the foundation of the framework, and then in following releases, we will migrate the existing internal teams. Then further down the line, once we work out all the kinks, we will then open it up to certain partners, then to the general public. The dynamic plugin framework will be the ultimate enabler that will allow internal and external add-on operators to create some very cool solutions on top of the OpenShift platform. Next slide, please. In 4.6, we introduced Quickstarts as a new onboarding pattern that has the major benefit of guiding customers with an interactive experience, reducing the time it takes to get customers up and running. Now, in 4.7, Quickstarts are extensible. Operators and customers can utilize the console Quickstart CRD to easily provide their own Quickstarts. Additionally, we will add hint interactions that allow users to highlight components of the UI. Also, in 4.7, our Quickstart catalog has been enhanced to be more scalable, now supporting filter by keyword and status. Post 4.7, we will provide additional enhancements, starting with embedded CLI commands. Additional items in our backlog are easy access to Quickstarts from topology for the developer, resizing the Quickstart panel, grouping mechanism for related Quickstarts, and much, much more. So keep an eye out on this area. Next slide, please. In 4.7, developers now have the enhanced developer catalog experience. A developer catalog contains a number of subcatalogs, each with their own set of features. Developers will have the ability to see all offerings in the developer catalog, along with the ability to filter by category and or keyword. Cluster admins will have the ability to customize the available categories in the developer catalog now, and the categorization component works off a default set of categories. These categories are only displayed if it has associated items in the catalog. So subcatalogs will include items like builder images, event sources, Helm charts, managed services, operator-backed services, Quickstarts, and more. A customized experience is available when drilling into a specific sub-catalog, exposing additional catalog features. For example, in the future, our Helm chart catalog will have the ability to filter by available chart repositories. And finally, cluster admins with RBAC can limit what developers are able to see and access. Next slide, please. All right, so building on a solid foundation, we have a one-stop show for application monitoring. In 4.6, users have the ability to view and silence alerts as needed, exposing alerts on workloads in the topology view for easy discoverability. Next we will provide a dedicated area to view target and associate status. This will allow users to know at a glance which workloads have custom metrics enabled. We're also working on pulling in performance analysis of Java applications, as well as integrated logs and tracing information. In 4.7, we've added the ability to see base image vulnerabilities in your project. In the future, we will enhance that experience to also include application vulnerabilities identified with our partnership with SNCC when the appropriate operators are installed. This integrated experience allows developers to identify and possibly fix application vulnerabilities at a much faster rate. Next slide, please. Moving on to the operator framework. The operator catalog in OpenShift has grown significantly in the last OpenShift releases. Over 300 operators are now shipping out of the box with every cluster. So there's a renewed focus on a smooth update experience with more controls for the cluster administrator to specify which kind of updates happen at which time. We also want to enable better insight into dependency resolution between operators, so cluster admins can see upfront which operators will get installed as a dependency. For developers, we want to provide a broader choice of programming languages to create operators, and we're looking at a prototype design for Java and Python operator SDK as early as next release. Beyond that, we aim to make it easier for developers to design the level 4 and level 5 operators by creating rich libraries with reusable components and models to cover application management. Next slide, please. So here's an example of how we want to make operator updates easier to plan for. Smart updates allow cluster administrators to define a policy for operator updates in which patch releases are applied automatically, but change in minor or major versions are waiting for explicit approval by the admin. This balances our desire to regularly ship operator updates to fix CVEs and Z-streams with the predictability of change sets due to an operator update in production. Next slide, please. Another way to make operator updates more robust is to actively communicate with service that it's about to be updated. In the next release of OLM, an operator can communicate a non-upgradable state. This makes sense for critical operations that should not be interrupted, like an application configuration change, or, for example, in the case of OpenShift Virtualization, the live migration of the VM. OLM will delay any update until the operator finishes the operation and reports a readiness for upgrade. This operator to OLM communication might also prove useful for other scenarios like missing subscription licenses for paid operators. Next slide, please. Moving on to Helm. So Helm is one of our most popular package managers for Kubernetes, and now that it's GA'd on OpenShift, we'll continue to integrate its capabilities across OpenShift. The goal is to provide a self-service application development experience that makes the OpenShift tagline, innovation without limitation, a reality, by enabling developers to use the tools desired and deploy their applications with minimal intervention and greatly reducing application time to market. We will continue to bring greater integration with the various developer tooling and services, including ODO, service binding, operator, dev files, and more. All right, next slide, please. All right, so moving on to Quay. So Quay is becoming an OpenShift native registry. Not only does it run well on OpenShift, fully autonomously managed by the brand new Quay operator in 3.4, but it will natively integrate with OpenShift monitoring, alerting, logging, and authentication, aiming for Quay 3.5. Many of our OpenShift clusters are running in a disconnected environment where Quay aims to help streamline the process of creating and maintaining a mirror for OpenShift deployments. And then finally, in a multi-cluster world, Quay is the central registry for all Kubernetes artifacts, not only for container images, but also for Helm charts and operators. Naturally, Quay will be used by many different clusters and tenants, and we aim to provide better support for the ops teams running Quay by adding more controls for the super user and quotas to prevent noisy neighbor syndrome. Next slide, please. Another important area is support for larger multi-tenant deployments. To support the multi-cluster landscape, our customers are steering towards Quay, and we will introduce quota management in 2 steps. In the first step, in Quay 3.5, quota reporting will be introduced where various metrics like storage, consumption, network egress, and register operations like pools or builds are counted. This will enable reporting and showback. A soft enforcement mechanism will follow that allows to create notifications for tenants surpassing their quota. In the next steps, quota enforcement will be enabled, which can be configured to trigger throttling of network traffic, builds, or initiate pruning, starting with older container images. There will also be options for Quay administrators to temporarily exempt users and organizations from their exceeded quota. Next slide, please. For public sector customers in North America, the Fips certification is very important. Quay so far was not supported to run on Fips-enabled OpenShift clusters, and Quay is not Fips certified by itself either. With the rebase of Python version 3 and Quay 3.4, there's an opportunity to unblock Quay on Fips-enabled OpenShift clusters. In Quay 3.5, we aim to fully support Red Hat Quay running on top of OpenShift Fips mode, which seems to be the largest blocker for government agencies as of today. Later in 2021, we're aiming to certify Quay itself with Fips certification. Excuse me. Next slide, please. I'm going to pass this off to Csi now. Thanks, everybody.
Thanks, Ali. So moving on to what's coming throughout next year around serverless and service mesh add-ons. Around serverless, one of the major focus areas are day 2 operations. So we have had serverless in OpenShift. It's already GA, and customers are adopting through the user experience that is available through CLI and console, deploying applications, serverless applications. But as these applications move to production, there are more capabilities needed around monitoring these services, the serverless workloads, be able to make decisions on their performance and get that feedback back to the development cycle. So that's one of the areas to bring more insight into these services deployed, and also focus a little more on the delivery cycle and the CI/CD flows and GitOps flows for delivering these workloads. These are applications like any other applications that need to fit into the existing CI/CD or delivery flows that customers already have. Another area of focus is integration and ecosystem, especially around the event sources. So what serverless enables for most is an event-driven architecture, and it's very important to have a very rich ecosystem of event sources available that we, through Red Hat products or partner products, ISVs, that customers can integrate into their application, consume these events, and be able to build workloads around it. And last but not least is developer experience to incrementally improve the experience that we have across the developer tooling, not just the console, but also CLI and VS Code and Intelligent and other ID plugins that we might be working on throughout the next year. On the service mesh side, the scaling service mesh, it's a big area that touches on as customers have more and more OpenShift clusters. As provisioning OpenShift clusters becomes simpler and they deploy more of them, they end up having more service mesh add-ons also in each cluster. So there are capabilities needed for these service meshes to talk to each other, or in a federated approach, or be able to have shared control planes, for example. So having multi-cluster meshes in multiple use cases is an area of focus. Navigating service mesh and getting really started with understanding the use cases and the documentation and quick starts and other approaches to get customers started with it is another area to help customers understand the value of service mesh and integrate it into their applications. And also better integration with the rest of Red Hat portfolio on OpenShift, for example, with API management, with our delivery pipelines, Takedown and alike, is the next area, the major area that we've worked on throughout next year. Next slide, please. But more recently, what we're working on these two areas in the serverless platform function is an exciting piece that will be released as tech preview, really expanding the serverless capabilities to not just the applications running in serverless, but also you just bring your code and function and you don't have to worry about the deployment mechanism and configuration of it. Initially, it's based on Go, Node.js, Carcass, expanding to Vertex and Python and other type of runtimes. Support for running serverless on OpenShift dedicated on Amazon and ROSA. That's the next part that is coming. First, as an unmanaged operator to make it available on dedicated cluster for customers, and we're in discussions to make that a managed service going forward as well, so that customers can have the same OSD type of experience and the responsibility of management that is on Red Hat, have it around serverless as well. Eventing was moved to a GA, it releases GA last month as part of serverless, and there are more capabilities coming in the admin console for the admin personnel for dealing with events. Monitoring is one piece of that, but also to be able to bind event sources into serverless workloads. And one of these event sources are Kafka and integration with Kafka, and that's becoming generally available also in serverless. Around service mesh, the same story, this is a theme you would see across most of our add-ons in OpenShift, where we want to provide the same experience on OpenShift dedicated clusters and ROSA and other flavors of it, beginning with unmanaged and moving to managed throughout the year. Multi-cluster federation is another part that comes with Service Mesh 2.1, and expanding support to also workloads that are not running on OpenShift, like in virtual machines or bare metal, recognizing the fact that many of the applications customers deploy are really hybrid combination of container and non-container, and so be able to use the same service mesh across all these workloads. Next slide. I briefly touched upon serverless function. It's a very exciting area, especially that it really offloads a lot more of the responsibilities that application developers had to bear around serverless and put it more on the platform. You write a function essentially in your favorite programming language, Go or Node or Java, and based on build packs, you can deploy the function and run it in the platform, and the configuration and operations that are managed by the platform itself. There's a local experience available through a plugin for the KN CLI, the Func CLI, that helps you to build an image and build based on the function code that you have and deploy it on the platform. There are templates, and you can bind it into different type of cloud events. And as we are going forward, expanding the runtime support for what type of functions can run on this platform. Spring Boot are next. Python especially is important because there are a lot of AI/ML workloads that fit the function and serverless use case really well, and we want to tap into that community and make that available on OpenShift as well. Next slide. On serverless, on service mesh, briefly talked about a federated approach. On the left-hand side of the slide, what you see on service mesh 2.1. So there would be more capabilities for multiple clusters that they have service mesh installed. Service meshes be able to talk to each other and coordinate their capabilities. We'll have incrementally more and more features around this scenario. And moving later throughout the year, we are heavily involved in the Istio community alongside IBM as well around discussions to be able to have a central control plane. So we have multiple clusters that have service mesh enabled. You don't want to have one instance of control plane in each of this cluster, similar to how the federated mode looks like, but rather have a central control plane, and each cluster has its own data plane and be able to coordinate the mesh across these clusters. So that's come like more of a long-term through out the next year, toward the end of the next year. Next slide. Around DevOps and GitOps, through three main areas we're working on. OpenShift Builds that focuses on building images on the clusters, the evolution of existing build configs or classic builds that you might be familiar with. OpenShift Pipeline focuses on takedown pipelines for CI, and OpenShift GitOps focuses on Argo CD for enabling GitOps workflows, Git-based workflows for delivering application and configuring clusters. So in OpenShift Builds, V2 build pack strategy for Java and Node.js will be added to the platform alongside source to image and builder for Dockerfile builds that are already available. We are working also to build a community around this so that there are more community-based strategy for other build tools like Canico or Jeep or others that customer are using to be able to have the same experience, but as a community build strategy. Separation of build tools and runtime images is another area we're working on to be able to have builder images that contain the build tools like Maven and JDK, for example, and runtime images that are really lean so customers can create images that are very small and deploy on the platform. Volume support and dependency caching is also another area we are exploring within OpenShift builds to make sure that different type of volumes can be consumed, and also the builds are fast by caching dependencies for Maven and NPM and build systems that are similar. On OpenShift pipelines, metrics and trends is an area that are in closer beginning of next year will appear in the platform, so teams can get insight on how the delivery pipeline is performing and also be able to identify issues when there are anomalies. Pipeline as code is a major area to align the way that people build delivery pipelines more with the GitOps practices and treat Git as a single source of truth also for the pipeline definition. More assistance around migrating to Takedown. I can see on the slide that it's actually reversed. Jenkins to Takedown migration guide to help. A lot of customers ask us how they have made investment in Jenkins, but they would like to move some of those workloads to Takedown to provide them some guide and assistance on how that can be achieved. And we were working on getting OpenShift pipeline as well on OpenShift dedicated, and flavors of that initially as unmanaged and going forward as a managed service. Takedown Hub Integration also another area that we are pushing forward across our developer tooling. Takedown Hub is a place that people can find reusable takedown tasks and OSV tasks to build pipelines based off of, and it's already launched in the community. But we are bringing more integration into Dev Console and CLI and VS Code and IntelliJ extension so that you don't have to leave your switch context to go to a web browser and find these tasks, so you can write from where you are, install tasks, and use them in your pipeline. OpenShift GitOps, we will be having the first release toward the next couple of weeks, in fact, with a productized version of Argo CD. And we are also enhancing the UX around GitOps Application Manager CLI that makes use of Argo CD, takes down CLI and other technologies that we have to bootstrap a GitOps process. And there are views that counter that or map that in Dev Console that we're enhancing those that give you insight into what deployment environments your application has and which version of your application is deployed in each environment, which status they have, and history of those, to give you a more higher level insight of how your delivery looks like. The same about a managed service. We're working to get them on dedicated, as unmanaged, and later throughout the year as managed. And alignment with RACM, also the question that comes up a lot. So we're working on Argo CD being as the single and core GitOps engine, both on OpenShift and RACM, and expand capabilities to cluster provisioning and governance, policy and governance through RACM based on Argo CD. Next slide, please. Looking a little deeper into a pipeline as code. So this is a new mode that we are working on, and this would enable essentially to treat pipelines as a declarative syntax that lives only in the Git repository. So what you see on the slide, there's a .takedown folder in your Git repo that contains your pipeline. There is no pipeline on the cluster that user would manage. And based on Git events that are coming from that repository, that might be a Git commit or pull request, the definition of that pipeline from Git repo is pulled and executed on the platform, and the results are published to that PR, for example, that are accessible through the CLI or Dev Console under the repository itself. What you see on the Dev Console is really just the execution of a pipeline and the Git repository. You don't have a pipeline on the cluster that you have to keep in sync with what you have in the Git repo. So really doubling down on the GitOps concepts here and making sure everything is declarative and coming from Git rather than live objects on the cluster. Next slide, please. One request we get a lot from our customers when we talk about our DevOps portfolio is that they like and use the technologies that we're productizing and bringing, but they ask us, so how is best to combine this? How should my delivery look like? What should I do with the Takedown? What should I do with Argo CD? So our response to that is really the GitOps application manager CLI that we're building is an embodiment of our opinionated way to do continuous delivery using these technologies. So customer runs a command, can bootstrap, and that would generate the resources, generate a pipeline for the customer, generate a number of sample environments. The application would get deployed, configure webhooks, configure Argo CD, and really bring up that entire environment that you see on the right-hand side, that entire workflow that you see on the right-hand side of the slide, with that one or two command for the cluster. And from that point, they can go modify this cluster. So it gives an opinionated and integrated way of doing continuous delivery through GitOps practices with the offerings that we have available on OpenShift, and they can customize it after the tool generates this structure for them. Initially, we are using Customize as the customization and packaging and overlaying the config for different environments. We're looking at Helm as an alternative packaging, and also different type of secret management integration. Right now, still secrets is what is used throughout this tool. Next slide, please. So getting developers started with OpenShift. We currently have a local experience with OpenShift, that's code-ready containers, which is a little larger than you would like, and we are actively working on reducing the resources that it needs so that it can run with much less resources on your laptop, with below 6 gigabytes, really. And there are Katacoda scenarios. If you have ever run to learn.openshift.com, there are Katacoda scenarios that gives you an instance of OpenShift for 1 hour and a tutorial to run through. So we are expanding that concept with developer sandbox. It's a shared multi-tenant cluster that it lives for 14 days, and user gets a number of project and resources to be able to deploy applications and try out different technologies, and different type of developer and add-on services that we have are pre-installed in this environment. So it's really an environment that is ready for the developer to get started and start coding and experiment with various capabilities that we have on the platform and our developer tooling. And also a workshop version of that is really for running workshops for the public at conferences. A lot of our developer advocates used to use Katacoda for running workshop, which doesn't allow the user to play with the environment after the workshop finishes 2 hours later. So a version of that on IBM Cloud that would be available for running workshop that is available for 40 hours. So the first 2 hours, maybe the workshop executes, and people have 2 days after that to play around with the environment after the conference, for example. Next slide, please. So not only the getting access to OpenShift, but also there are areas we're working to help developers get started with various technologies that we have across different tooling that we have. So Odoo is an example of that, taking advantage of dev files to provide multiple type of Quickstarts that generate an application and sets up the environment for application for developers to start with. This is in ways similar to the Quickstart experience in Developer Console, but bring it to Odoo and more expanded way of getting developers started there. Bring in similar capabilities in VS Code and other IDE plugins that we create to be able to, instead of developers starting from scratch and trying to figure out how to build code and deploy code on OpenShift through different runtime and serverless and other capabilities that we have, to give them examples and start them off a much higher ground and push them through the flows that we have designed for them. Next slide, please. And in general, our approach throughout next year is to bring more and more emerging technologies and fold it into the existing developer experience that we have in console. So developers can easily get overwhelmed with the variety of technologies that we have available in OpenShift, like serverless and Istio, and there was Takedown and Argo CD, and on and on. The key to that is to make sure that this experience is really smooth and folded in, well integrated into the existing experience that exists around OpenShift, and that's the focus that we have for next year, to make sure that they are readily available as a part of the existing Dev Console experience, and also make sure that we can support more and more multi-cluster experiences as we see the trend that customers incrementally add more and more clusters to their infrastructure, so that they have applications that are deploying multiple cluster, and this through the same interfaces, through the same experience, so they have access to those multi-cluster deployments as well. Next slide, please. And with that, thank you for this section. I'm actually not sure who will be talking next.
So I'll go back to the slides for virtualization, so Ramon can finish his section, if that's okay.
Yes, thanks for that.
Or here, there you go.
Perfect, thank you. Okay, so we are in the Kubernetes native infrastructure section, and let's go about OpenShift Virtualization. And starting at the core of OpenShift Virtualization, something we're working on is GPU pass-through and vGPU supports. Those are, addressing intensive workloads like AI, ML, by dedicating GPU to the pods that require it. Then I'm highlighting a few important things of OpenShift Virtualization, and another one is the work we are doing for working with public clouds, particularly with AWS and IBM Cloud, that is using physical instances in these public clouds where OpenShift Virtualization needs to run. And something else we are working on at the core is, well, a tooling for mass workload migration, specifically from vSphere and Ref platforms into OpenShift Virtualization. Then on the networking side, one of the things is that we're working on as well is the live migration of virtual machines with SRIOV, right? Not an easy task to do. Think about, we are presenting SRIOV, which is slices of a NIC physical device into a virtual machine, and we are then moving this virtual machine into a separate host as well. So this is coming, we're working on that, and similarly we're also working on NIC hot plug to hot plug in and unplug your NICs in virtual machines. And we are continuously enhancing the Red Hat ecosystem for network partners. We're working with Tigera, Calico, And then on the storage side of things, what are we doing there? Well, one of the things we are doing is dynamically attach storage with hot plug to your virtual machines. And also with the intention of having less downtime while migrating workloads running on vSphere, we are adding support for warm import from vSphere. This will still require a reboot, but is faster than the cold migration. And then improvements in snapshots and cloning with storage solutions like OCS through the Csi interface, which results in better protection of the data using native Kubernetes capabilities. So this is with OpenShift Virtualization. Let's move to the next slide. And we're going to cover Kata containers. All right. So OpenShift sandboxed containers, Kata containers. And well, let me again highlight a few things in this slide. Operator. Well, sandbox. Let's start with the nature of Kata containers as driven by an operator. So sandbox containers are coming on bare metal, bringing Kata containers to OpenShift by an operator, right? Which will be using operating system extensions with a downsized QEMU build. Okay. The operator will be providing OLM-based installs, updates, and upgrades. At the core, Kata containers includes OpenShift CI and Cryo CI integrations to get changes. And then we'll use Kata 2.0, which brings metrics along for observability and footprint optimizations as well to the Kata agent in this case. And then on the networking side, let's call this networking plus, right, with IPv6 dual stack support and also more SRIOV and DPDK for Kata containers in this case. And let's go to the next slide now and talk about Edge. And Edge is a natural extension of the Open Hybrid Cloud strategy, right? Which I'm sure you all are familiar with, enabling any workload on any footprint in any location, right? And this is important because as organizations look at the best technologies to help them reach more customers, deliver differentiated experiences, drive innovation, we are talking about an architecture here, and your architecture options can't be limited to just centralized architectures, right? Edge is required. It's driven perhaps mostly by the telco industry, but you know, it's something you can use in many types of customers, and this is what we are learning. Let's move to the next slide and talk about a few things about Edge. Starting by topologies, talking about architectures. Topology that we are working on and a lot is a single node OpenShift. You heard it right, single node OpenShift in a specific use case for OpenShift Edge, right? Where you need an entire OpenShift cluster on the remote side, but you only have space for one node, right? This is pretty much the use case that we are learning this type of customers need, and we are really working hard to make this happen. More things important here. Well, you know, the assisted installer I was talking about before, one of the biggest additions to Kubernetes native infrastructure for the provisioning of bare metal nodes. Well, this also needs to be able to provide compact clusters, right? That is 3-node clusters. With bare metal API in 4.6, there was a question before in the chat. We support deploying a 3-node cluster already, right? You still need a machine to do the provisioning. Well, now with the workflow that's driven from cloud.redcat.com, right, completely online, we can also do this and provide compact clusters. What else? ACM. ACM is important in this type of use cases, and ACM cluster lifecycle now has integration with Ansible. And with this, you know, when deploying clusters with ACM, well, we're using IPI, we are using Hive. But this is not enough. There are so many types of topologies, use cases that bringing Ansible hooks to the table will allow us to cover a variety of use cases when starting with ACM and deploying multiple clusters. And then zero-touch provisioning. So the concept of zero-touch provisioning is I want to provision my nodes with barely any interaction. That is going to the data center, plug the node in, power it on, and have the node added in the cluster, right? With virtually zero interaction. Anyone could do that. And this involves many things, right? This involves, well, automating that this node needs to go to a specific cluster, it needs to be accepted, it needs to be ready to schedule workloads of the type that are required by every, remote site in this case. All of this falls into the zero-touch provisioning category, and we're doing a lot of work to make these use cases possible with OpenShift on the edge, right? And then timing and acceleration, again, these are use cases related to telco customers, right? A specific for workloads that work with real time, that work with SPARNICs, accelerators, hardware accelerators, etc. This is the line of work at the edge for OpenShift we're working on. And with that, let's move to the next slide. And in this slide, this is not strictly KNI. Now we're going to talk about OpenShift and OpenStack. And in OpenShift and OpenStack, if you think about this, we've been making progress since OpenShift 4.2. In fact, before OpenShift 4, but in OpenShift 4, essentially adding support to the installer started in 4.2. And I want to say that by now, OpenShift and OpenStack is a pretty mature combination and integration of all the services. So we are working on the deployment user experience in every release with UPI, with IPI, making it easier and easier to use and covering more use cases as we go. But I have to say, it's pretty mature at this point. We are going, and we are already focusing on some telco and edge use cases. OpenStack, if you think about it, is one of the most popular platforms in the telco industry, right? In the telco market, there are loads of OpenStack deployments, and obviously they want OpenShift in these deployments as well. And this brings a lot of flexibility as well, having VNFs along with CNFs together in the same platform. And then another point that I'm covering in this slide is the integration with bare metal. Another thing that OpenStack is allowing you to do is to manage bare metal nodes as if you were managing virtual instances. And we take advantage of this with OpenShift, having the installer in an OpenStack platform that allows you to provision bare metal nodes. Provision the nodes, the OpenShift nodes now, on bare metal or in a combination of bare metal nodes and virtual machines. This is something that's available, and we are about to release full support for that, but the technology is ready there for you to test. And let's go to the next slide and see a few more things about this integration and what we are working on. And at the core, as I said, we're working on bare metal workers. We also, I said this is pretty mature, but thanks to the feedback of our customers, we have very close relationships with a number of customers using OpenShift and OpenStack. And some things that they are saying, one of them was saying, well, not one of them, when I'm using auto-scaling with OpenShift and OpenStack, I still need to have at least one node in there, and that costs money to my customers, right? So we are now working with auto-scaling to and from 0 nodes, right? So when you don't have any work to process, you don't need any instances, you are not paying anything. As Catherine was talking at the beginning of this presentation, we're also working on introducing the external cloud provider as opposed to the in-tree in the Kubernetes code provider that we have right now. More things. On the network side of things, as I said, part of our focus now is covering telco use cases, and we're starting by adding support in fast data path with SRIOV and OVSDPDK. And hardware offload. How does that work? Well, essentially, we are allowing pods running on virtual machines that run on OpenStack to use SRIOV, right, with the SRIOV operator, and the same for OVSDPDK. On the network side of things, we're also working on bring your own load balancer and DNS. Similarly to bare metal in OpenStack, when you provision an OpenShift cluster, we also provision a load balancer and a DNS. Infrastructure actually is the same than the one we use in bare metal. And well, we are working on allowing you in a very easy manner to bring your own load balancer, if so you wish, and the same for DNS. We're also working with full support for provider networks. This is common in many customers, enterprise and telco type of customers. And well, Courier, which is our CNI, right? A CNI that understands that's working with OpenShift and with OpenStack, optimizing the traffic for this integration. And we are adding support for IPv6 dual stack. This is a common pattern across many providers in OpenShift. And then moving to the storage section, well, again, as Catherine was introducing earlier, SIEM CSI is something that also we are working on. We believe very soon you're going to have SIEM CSI by default. And as part of SIEM CSI, you have a CSI topology in general in Kubernetes that we want to support also as part of the storage integration in OpenStack with similar availability zones in particular, right? So you will be aware of the availability zones when you create PVs for your pods, and you will be able to influence where these PVs are scheduled. And with that, I finish this section. And
right. Well, thanks, Ramon. Man, Kata containers right after Kubert, nothing slows you guys down. A machine. So I'd like to thank everybody for joining. It was a great session, and these slides are available. The recording is available. 2 quick things. Remember to come back once a quarter. This roadmap will change, and we'll update it once a quarter for you. Also, anything that enticed you that you want to hear more about, there are deeper dives available. So grab the closest Red Hatter to you and get them connected to us, and we can dig in deeper on any of these topics. Also would like to thank everybody out there in the world for the call for papers for Summit that closed last week. We had so many awesome public customers that want to talk about their usage of OpenShift that we will be having those sessions on OpenShift TV and OpenShift Commons and at Summit. So really give a lot of exposure to the amazing things that people have done with the platform. And from all of us at Red Hat and the OpenShift community, we'd like to wish all of you the happy holidays. Stay safe out there. And